Okay, folks, let's start with Chapter 1, Section 4. It's on measuring angles. The first two sections were just an introduction to geometry. We talked about different type, how to name lines, how to name segments, and how to name all the, we talked about the difference between a point, line, and a plane. And actually, now that I mentioned the point, line, and the plane, those are the three undefined terms of geometry. Now, the question is, why are they the undefined terms? It's because they have no shape. They have no shape and they have no size to them. That is why they are considered the undefined terms of geometry. All right. Now, today we're going to be talking about how to measure angles. Now, we talked about an angle is being two rays that are joined at a common endpoint. That's called the vertex point. We'll talk about that here in just a moment. Before I do that, I want to mention to you that on this week's module, you will see a discussion question. The question is, what can I, Mr. Brewington, do to help you reach your goal of getting the most out of this class? It's actually, how can I help you the most with all this hybrid learning and all the new changes that have gone on recently through this school year? It's not easy. It's not easy for any of us, and I'll tell you that for me, it's been a struggle as well, and I completely understand that. So when you get on there, just type in a few sentences, maybe a short paragraph or two about what ways that I can help you and help you navigate yourself through this. Okay. Now, today you'll be able to determine the relationship between each of the measures given the information. Okay, first of all, you need to know what an angle is. An angle, by definition, is a figure formed by two coplanar rays with the same endpoint. Now, that endpoint that I want to emphasize to you is called the vertex point. This right here is an example of a vertex point. This right there is also an example of a vertex point. They're the common endpoint at which both rays originate. And just so you know also that the two sides of the rays are called sides, two sides of the angle are called sides. They're the rays that form the angle, but they're called sides. I'm going to highlight that in blue. I like the color blue, not just because it's school colors, but I just like the color blue. Not that you really need to know that, but I'm going to tell you anyway. So there you go. All right. So there's multiple different ways in naming angles, and it just depends. All right. So what I'm going to do here is I'm going to go ahead and take this angle, and I'm going to give it 3 points. I'm going to give it a point here. We'll call that point A. We'll call the vertex point Q, and we'll call this point here, we'll call it T. When you're naming an angle, there are some things that are very important. For instance, one thing that these angle names both have in common is that the vertex point is in the center. That is vital. The vertex point must be in the center when you're naming. So, for example, I can also, since this is a standalone angle, that means it's all by itself, I could just name it by its vertex point. So any one of these three will work. And the same thing, I'm going to go ahead and do one over here. Let's call this M, B, Q. Or we just use Q. Let's go P. So angle M, B, P. I even made a mistake there. That's what I like to call an oops. I do a lot of oopses from time to time, so I'm not going to stand up here and tell you that I don't make mistakes, because I do. All right, so angle P, B, M, or simply angle B. I can name the angle by its vertex point as long as it's by itself. See, both of these angles are by themselves. It's the only angle, so you can go ahead and name it by its vertex point. Now, in some cases, there may be there may be, like, say, a number. Let's say there's the number 3. Sometimes they'll throw a number inside the angle or a symbol or something of that nature, and you can go ahead and name the angle by that symbol or by that number, as long as it's inside the angle, just like you see there. All right. By the way, outside the angle is the exterior, inside is the interior. Let me say that again. Exterior, interior. I'll even write that down for y'all. This is the interior, and then now here is the exterior. All right. All information that you need to know about angles. All right. Now there are four types of ways of classifying angles, and it's by their measures. First is the right angle. I believe you all know what a right angle is. It is simply an angle that has a measure of 90 degrees. So, for example, when you see a right angle, you'll see a little square in the corner. Now, my square isn't the best, but as you know, my writing's not the best, but you get the idea. All right. Any angle that is less than 90 degrees is considered acute. So this is an example of an acute angle. Right here is an example of an angle that is greater than 90, but it's less than 180 degrees, and that's called obtuse. And then, of course, you have your straight angle. Now, we've already talked about straight angles in this class, but we've classified them by their other names. There were two names we classified them before. One is a line, and then the other is opposite rays. Okay, let me clarify that. Straight angle, opposite rays, a line. They're all the same. Make a note of that because you will see that on a quiz or a test most likely. When I usually say that, that means it's probably going to happen that way. So make a note of that. All right. So, but that's the way to classify the angles. All right. Okay, once again, this is a reminder. An angle, you classify angle measure. Oops. Let's try to go back up just a hair. Anyway, a right angle. Sorry, I have a little problem with the PowerPoint. Right angle. 90 degrees. Acute. Less than 90 degrees. Obtuse. Greater than 90 degrees, but less than 180. Very specific. Greater than 90, but less than 180 degrees. And then a straight angle is exactly 180 degrees. Its other names are line or opposite rays, which we talked about in previous sections. All right. Now, one thing I do want to mention is the postulate 1.7 is the protractor postulate. And it says the number of degrees of any angle is somewhere between 0 and 180 degrees. Sometime in a later lesson, I'll show you how to measure on a protractor. And then when we do that, you'll see just exactly what I mean. So, all right. And congruent angles have equal measures. Okay, just a couple things you need to know. All right. Okay, little reminder that an angle is formed by two coplanar rays with the same endpoint. The two rays are called sides, and the vertex point is the common endpoint. I'm telling you this again because I really want you to get a grasp on this. And then two ways to name it. To name an angle, by the vertex or by a point on each ray along with the vertex. You saw how we did that here just a minute ago. You can always rewind back if you need to. All right. Now I'm skipping over one of the slides because this slide right here, as you can see, is a repeat of the previous slide, so I'm just going to leave it. But we will go to this one, postulate 1A. It's called the angle addition postulate. It says if point B lies in the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. All right, I went through that pretty quickly. That probably sounds confusing when I say it. Here's what it means. All right, I'm going to group these angles by color. AOB is the red angle. BOC is the blue angle. And AOC, the whole thing, is the green angle. Here's what it's saying. It's saying the red angle plus the blue angle equals the green angle. That's what it's saying. Let me say that again. This red angle plus this blue angle equals the green angle. That's what it's saying. And I'm also even going to underline these particular colors. So here's what I do. I've also underlined the information, and I'm looking for the measure of angle COB. Now, one thing I'm going to note, it says find the measure of angle COB. It's also the same as the measure of angle BOC. It's the same angle, it's just rewriting it in different ways. I can flip the letters around as long as the vertex point stays in the middle. That's the key thing, is that it has to stay in the middle. All right, so with that being said, here's what I'm doing. I'll plug in my numbers. The first number here is 45. My blue, I don't know what it is yet, so I'm going to call it X. I'm just going to call it X. Anytime you have an unknown, you just got to give it a variable. In most cases, we use X. You could use any variable you want, but in most cases, we just go ahead and use X. Okay. Now, angle AOC is 123. So here's what I have. Here's my equation right here. I'm going to highlight it in green. That's the equation I'm going to use. And I'm going to bring it down here. So measure angle AOB plus the measure of angle BOC equals the measure of angle AOC. Now, it's confusing when I say all those letters, so I'll underline it. Red, blue, and green. Red, blue, and green. So now I plug in the numbers. I got 45 plus X equals green, which is 123. And when you do the algebra, which I'll just do over here to the side, X equals 123 minus 45. Let me rewrite that. That looks bad. Normally, even my equals 123 minus 45. So that means that X is going to equal 78 degrees. Do not forget to put the degree symbol when you're writing that out, folks. So that means that the measure of angle COB equals 78 degrees. Now, there's a little bit more for us to cover here, but I'm running out of time for this video. So I'm going to stop this and we'll continue this with part 2.